Hello, in this video we are continuing our discussion of section 8.4. Now specifically we are talking about the root test, and we are going to apply it in example 8 to test the convergence of the series, the sum from n equals 1 to infinity of 2n plus 3 over 3n plus 2 all raised to the nth power. So what we will do here is take the nth root of the absolute value of our terms. So that means we're going to take the nth root of the absolute value of 2n plus 3 over 3n plus 2 raised to the nth power. And notice that since we are taking the nth root and raising it to the nth power, those do cancel out, so that we are left with simply the absolute value of 2n plus 3 over 3n plus 2. And since n starts at 1, those values are all positive, so we can drop off the absolute value. So then, for the root test, we need to look at the limit as n goes to infinity of this nth root of our term. So that means the nth root, or the limit as n goes to infinity of 2n plus 3 over 3n plus 2. We can evaluate this limit by multiplying by our highest power in the denominator, which is an n, or multiplying by the reciprocal, so it would be a 1 over n in both of those. So this ends up being written as the limit as n goes to infinity of 2n times 1 over n gives us a 2, plus 3 times 1 over n gives just 3 over n, all over 3 times 1 over n gives 3, or 3n times 1 over n, and then plus 2 times 1 over n gives a 2 over n. So now as n goes to infinity, 3 over n is going to go to 0, 2 over n is going to go to 0, so we end up with 2/3. So, similar to the ratio test, we have set up something and simplified it. We have evaluated a limit, and then in the third step we need to come to a conclusion. So this value is less than 1, and that value being less than 1 means that we can conclude that this series converges. In this case, it will converge by the root test. Now, this problem only asks us to test for convergence. Oops, and I definitely missed that word. That's very important. There we go. The series converges by the root test. So this says to only check for convergence, but just like with the ratio test, we could have actually concluded absolute convergence here if that's what we were wanting. But in this case, we're just simply going to write convergence because that's all the problem is asking us for. So our final answer for example 8 is that the series converges by the root test.